So let's start recording.
Okay.
Okay, so let's open up the accompanying blog article. So online, you'll find on my website, archives.robagain.com, a accompanying blog article that I will update over time with more methods on how to set up a project for use, specifically a template project, specifically used in HIS, and it contains a whole bunch of configuration files and default starter configuration files in your Visual Studio Code project, so that you can just hit one button and then Visual Studio Code will automatically start debugging you or start debugging the code that you've run.
Can you see the? Can you confirm if the recording is on?
Yeah, it is. Yeah, it's recording.
Okay.
Mic, yeah, the mic is capturing.
Yeah.
So you can find on the blog article the link with the template. And this just contains a default CPP file, a README, your git ignore so that it'll, don't upload your build files, and a .vs code with all of your launch configurations. And what you do is you'll want to sign into GitHub, and you'll click the use this template button, and you'll want to create a new repository. And let's just call it lab 7, why not? And I would recommend sending it to private, because you don't want the others to know what you're doing, right? Otherwise, we would all be copying each other's code. And then you'll click the create repository from template button. And GitHub will then go ahead and create a new repository for you with all of these default files. And then what you can do is you can go and click the code button, and you can just, do you use SSH or HTTPS? You don't know. Okay. You go ahead and copy it, and we'll use the terminal.
Wget.
Where's your project directory?
I don't have a specific.
Okay, well then I'll just do it on the desktop.
I think.
Yeah.
You will create a new one.
CD desktop, and we'll git clone the project, and this will clone into lab 7.
So it will download.
Git credential SX chain wants to use your confidential information stored in github.com in your keychain.
I think 1, 2, 3, 4, 5, 6. Okay, my GitHub.
No, the password for your computer.
Okay, 1, 2, 3, 4, 5, 6.
Sorry.
Yeah.
Okay. And that'll clone your repository, and then you can use code. I don't know if you've got it linked. Never mind. Okay, then we can open it up with Visual Studio Code. Let's just open up a new project. And let's go to the desktop, and here we'll search for lab 7, and we'll open it up. And Visual Studio Code will start opening up. Now, the first thing you'll want to do is Visual Studio Code has a extension pack with the C and C++ expansion developments. This will basically give you IntelliSense, so it'll show you like the properties of a variable and like the structures and everything. And so what you'll want to do is you'll want to go to the extension marketplace, and you'll want to search for @recommended. And it'll show you workspace recommendations. You can ignore dev containers. And here already the C and C++ extension pack is already enabled, but you'll want to make sure that that's enabled or installed. You can either enable it globally, and that you'll only have to do that one time, so every time you use Visual Studio Code it'll always run, or you can enable it for this workspace if you're not using C or C++ code as often. And basically what you can do is you can go to your files, and you can open up your first problem, and now you're ready to start coding. For example, let's do a basic cout. I've also included a using namespace std so that you don't have to always reference the std. For this time, I'll just do like that. And we'll add an endline to it. Then we can save the file. And then up here, or in here, we have multiple build and run configurations. You've got the build and run configurations. These will build, they'll compile your project and then it'll run it. And you also have the option of opening the external console. In macOS, this will open it up in terminal. Since Visual Studio Code doesn't support capturing input within their own debugging terminal, you'll have, if you're using cin or getline or whatever, you'll have to generally run it in a external console. So the default is build and run in external console, and we can either do it through here. So here we can do debug C or C++ file. And here it'll give us a bunch of tasks. These are like pre-computed, but just ignore those. And here you've got build and run external console, so you click that. And it'll build it, and then it'll open it up for you in that build finished successfully. And now it should open it up in your terminal. It takes some time the first time around. In fact, it's still computing up here. There we go. So Visual Studio Code wants to access control terminal. Allowing control will provide access to documents and data in terminal and to perform actions. Now, this is one of the first things that Visual Studio Code needs admin access for, because you'll need administrator access to modify the setting in privacy. There you go, developer toolchain. Again, even though you don't generally need debugging to debug these simple programs, like admin to debug these simple programs, unfortunately Visual Studio Code wants admin. And I'll be working on another part of the blog where you can run a simple virtual machine using some default images, and these will already have your Clang, your compiler, and your administrator access, so that you don't need to run it on your host. And there's an extension called Remote Development SSH, which allows Visual Studio Code to operate within this virtual machine without doing much. So continue. And here we have, okay, we took too long because Visual Studio Code thought it had died or something, so we can use run again, external console. We don't need to build because it's always the same code. And here you go. Have used Sanamad. Here you go. Process executed with status 0. And that's basically it.
Yeah, perhaps like you can add a while loop and show them.
Yeah, sure. So another example, a while loop.
Printing the name and with the indexes 5.
So for example, we will do a string array. Give it a name. Name is equal to.
This two will become later.
I'll fix it up in a moment. Hassan Ahmad. Missing initializer.
The brackets will come later.
Ah, that's right. That's true. There you go. Expected an identifier.
Give it a size maybe for 3. Oh, it's a spelling mistakes.
I don't know. Actually, it's probably easier for just to an integer like. It's actually the list is like this, right? Yeah. 1, 2, 3, 5, 9. And we'll go.
You will change the size.
Oh, integer I is equal to 0, so. Shows. Accidentally compiled. I must have clicked the top bar. Okay, so I smaller than size of the name array divided by the size of a integer, which is 0, and then I++. Ooh. Here's an extra 1. Okay.
You have to change the name, the size of int name, and 3. It is not 3 anymore.
Oh, that's just reference it like So you can do then cout name at integer I and end line. Now sometimes IntelliSense will just bug up, so you can just run it again. We'll then run external console. This should be valid. Yep, build finished. Then I'll launch in here. 1, 2, 3, 4, 5, 6, 7. To show the difference between external console and normal integrated console, if for example we are if for example we are getting input, so for example int number and then cn number, I will show you, for example, cn number, number. Okay. So if we were to use the build and run without the external console, it'll build the project and it'll open up in the debug console. And I would like to access files in the desktop folder because it's running in your desktop folder. It'll bug up here because the debug terminal, the debug console, this thing here, this thing where we can type in, it's used to capture the values of variables, and I'll show you how to use the debugger in a moment. But the problem with that is it doesn't currently support input, so we always have to use the external console. But if we're not using the external console and we're getting our values elsewhere, or we've already predefined them, we can just generally use the debug console without having to open up because personally I like to use my Visual Studio Code in full screen mode, so I get the most screen real estate, and it'll open up to the side, and it's just kind of annoying, so just keep that in mind. Okay, so actually building and running and debugging. So to access the debugger and to set breakpoints, what we can do is we have to look for a line that we want to look at, and we set breakpoints. Breakpoints basically mean that the debugger will stop at that line before executing it, and you can debug and you can see what the values are there in the moment. So if we run, remember to always, because it'll always say debug or run C++ file, you always want to debug. Running it will just run the file without any debugging, without looking at your breakpoints. So debug C/C++ file, build and run in external console. And this should open up in a minute now. Okay, so it prints Hafiz Hassan Ahmad. Currently nothing is happening because it's currently waiting for the input from cin. So we'll give it a number, 1, 2, 3. And there's our breakpoint. And it showed us that it's currently stopped there, and we can go to the run and debug pane, and we can look at the number. We can look also what name is currently set to. It's currently more or less stopped here. Like it's done this part, but it hasn't done this part. And in C++, it'll assign random values depending on what the memory is, what the heap. Because like when you delete a variable, it doesn't just set the entire memory that was taking up that space to 0, 0, 0, 0. That would take time because it would take time to set all of the values. So basically, it'll just say, okay, this memory is free, but any of the data in there is not set to 0. It's just any random data. And this can lead to a lot of hacking and a lot of exploitation. For example, like hackers getting higher privileges in your machine. They can use exploits by accessing memory that is free and that they can use, but hasn't been set to 0, and so it might contain private information. But that's a discussion for another time. And we can see these values that were in memory before, that were freed memory, but it hasn't been set to anything, and we can see these random values. And we can also skip to the next, and blah, blah, blah. Then, going to the next breakpoint and continuing. Continue, we'll just exit and continue to the next point in code until it reaches the next breakpoint. Step over will basically, like, for example, if you've got a for loop, it'll run it and it'll just step over, like it'll just ignore the thing, and like run over to the next breakpoint or just go to the next instruction. Step into, and we'll see this in a moment, basically it steps into the next instruction. For example, this is the best example is in a function. Step over will run the function and not try to debug the function. Step into will go into the functions, what the function is doing, and it will look at what the function is doing and it will debug it for you. Step out of, just reverse of step into. So continue, and here we have currently, now we're stopped here before the for, and we can see our variables, number 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. And we can use the debug console to execute and check for some variables or some logic. So for example, we can do give me the value of number plus name at value 2, 126. And we can also call functions in here. We can do various different things.
So it is 123 plus 3
Yeah.
is equals to 126.
Right. So
The number we are having in the current state.
So currently we'll look at step over and step into. Step into, we'll see how there's no breakpoint here, but it has stepped into the next instruction. As I said, in a function, it will look into the function and will start debugging the function. And step into again, we'll go to the next instruction, again, next instruction, or
So
step.
I value is changing.
Yeah, step over, basically just exit out of that and just continue going, and now it's done. And we can see it is still running for some reason. I think I have to click continue. Yeah, there we go. And that's it. Process exited with data 0. That's basically all of it. That's the debugging.
Yeah, I think like you can show them the whole loop, how it works, and how the values are changing over here, because this is the purpose of
for example,
debugging. So
we'll add number plus equals name I.
keep it simple, like number is equals to number plus.
And then we'll just add some extra formatting. And then number. So currently we'll look at these instructions. Again, debug C++ file, build and run an external console. Terminal. It'll launch in a minute. There we go. If this is a number, let's give it a number, let's say 1, 2, 3. Okay, so first instruction, and it hasn't executed it yet. Number is currently equal to 123, I is equal to 0, and I at name at position I, in this case 0, is equal to 1. So we'll continue to the next breakpoint. We can now see that number has become 124, so number plus equals 1. Now it will be printing to the console the value, so let's do that again. And now we can see in our console the value 1, and the number is equal to 24.
123 plus 1.
Yeah, 123 plus 1. So again, one number is 124, the next value is I, and name at index I is equal to 2, so 124 plus 2 is equal to 126. Let's continue. Now it's become 126. Let's print that. Again, 2, I name at index 2 is equal to 3, so 126 plus 3 is equal to 129, blah blah blah. And also during debugging we can toggle and enable breakpoints whenever we want, and that will just execute and it'll exit. And we can see our whole value here. There's also watching. Watching allows you to watch for variables, for the names. And we've also got the call stack. The call stack allows us to see where this function is currently being called from what, where, when, and we'll take a look at this in a moment. So let's build and run in the external console. There we go. Should open up a new shell. Execute. This is on mod 1.23. Number, we can watch for specific values in watch, so showing us currently number is equal to 1 to 3, but we can also see it here, locals. We can also see our registers. So for example, we can see currently the memory values of these different instruction sets, but that's way more low level than this class is currently for. And we can also see the call stack. It is currently called by problem 1 method or function main, and we can see that it's currently line 11, column 1. And we can also see that it is currently being called by a unknown just-in-time compile code, and this is the terminal. The terminal executing this code, but it doesn't have access to that information, so it's just saying unknown. Yeah, that's basically. You can also toggle and disable all of your breakpoints quickly if you just want to run through it. That's it. That's basically the extent to which Visual Studio Code has debugging. It also this is also applicable to all other languages that support debugging in Visual Studio Code. JavaScript, you can do the same. Also, in, you can watch variables, call stacks, and stuff like that. And that's it. That's how you use it. And then, of course, if you made a change, you can use just git. Let's commit this, for example, changes, commit, say sync changes, and action will push and pull comments too. Yeah. Oh my god. No, it just keeps asking.
Yes.
Yeah, get fetch.
So this will make a change in a GitHub.
Yeah, and that's basically it. And but that's the that you should have already learned last year. Yeah. And code 37 seconds ago. And that's it.
Thank you so much.
Yeah. Yeah, there is support. Currently I'm adding support for dev containers, so allows you to open it up also up in code spaces, or you can open up the project. Let's search for the Lima. Here it is. No. Where's the Lima part? Here we go. Lima. And Lima VM is something for macOS which allows you to run virtual machines within your within your user, not as like admin, but within like root, but as your user, and it makes a lot of stuff very much easier. It has support for Docker within the thing, and so you could use dev containers if you want to, but that's just a waste of resources since you're already running a virtual machine. But that's under the hood details. Yeah, so search for SSH. Yeah, SSH default port in Lima is localhost 60022. And that's it. Thanks for